Hi, I hope you've had a good day so far. Okay, so we're going to have a look at decimal multiplication. Brilliant. Okay, it's good when it works, isn't it? So fantastic technically. Bit of tongue in cheek there. Okay, so number one, 5 multiplied by 0.5. 5 multiplied by 0.5. Okay, so 5 lots of 0.5. We know 0.5 is the same as saying half. So it's like saying 5 halves. So I've got the dog down here curled up. No. To show you one time. Okay. So we've got commutative means it works both ways. So addition is the same. So what I'm saying by addition, the reason it works both ways is 2 plus 3 is exactly the same as saying 3 plus 2. They're both the same. 2 plus 3 is 5. 3 plus 2 is 5. 5 is 5. They're both the same. So what it means is multiplication. If I wrote 0.5 multiplied by 5, the answer would be the same. We could do that actually. So let's do it like a multiplication, but instead of doing that 5 there, I'm going to put 0.5 at the top and I'm going to multiply by 5. So actually I would do it if I did 5 multiplied by 0.5. I wouldn't do it that way. I wouldn't write it that way. I'd strongly suggest that you don't do it this bubbly way here. So we've got, then we put a decimal point in. 5 times 5 is 25. 5 times 0 is 0, plus the 2 is 2.5. Right, let's try it this way though. So 5 multiplied by 0.5. Can we do it the same? 5 times 5 is 25. 5 times, there's a 0 there. 0 plus 2 is 2.5. But this shouldn't be there. So let's rewrite it and put that 5 in the place it's supposed to be, because that isn't 5 tenths, it's 5 ones. So I wonder whether that means we could put the decimal point in the 0. Let's have a look. 5 times 0 is 0. 5 times 5 is 25. That feels really uncomfortable, doesn't it? If 5 times 0 is 0 and 5 times 5 is 25, you sort of, do you see why it's confusing? So I strongly suggest when you have multiplication of a whole number and a part of a number, you do this. The other option for you to use is you take out the decimal places. So we've got one decimal place we've taken out there. So now what we could do is 5 multiplied by 5. We know 5 times 5 is 25. But here, this means we've got to put back in one decimal place. So in this number, we've got to have one decimal place. So that could be in the decimal place, and we can put our decimal point there. That was really bad, wasn't it? We could put our decimal point there, and now we have 2.5. So perhaps we could try that with something else. Let's have a look. This lime green colour. Number 2, 1.5 multiplied by 5. Okay. 1.5 multiplied by 5. Right, I'm going to do it this way. But I'm also going to do the way where I take out a decimal point place. So let's use the same colour actually. I'm going to take out one decimal place and I'm going to do here 15 times 5. So we've got here 5 times 5 is 25 and 5 times 1 is 5, add 2, 6, 7. So I think the answer is 7.5. Let's see. 15 times 5. Okay. We could do 10 times 5 plus 5 times 5, or I'm going to do 15 times 5 here. 5 times 5 is 25. 5 times 1 is 5, add 2 is 7. But we've got to put our decimal point back in. So we've got 75, decimal place, 7.5. Yes, the same. Okay. Number 3. 17.2 multiplied by 3. 17.2 multiplied by 3. Okay. I'm going to take out a decimal place. I'm going to do 172 multiplied by 3. 3 times 2 is 6. 3 times 7 is 21. 3 times 1 is 3, 4, 5. 516. Put my decimal place back in. So my answer is 51.6. 1, 2, 3, 4. 10.05 multiplied by 15. I'm going to take out 2 decimal places. So I'm going to do 1005 multiplied by 15. I'm going to do long multiplication here. Okay, so I've got my ones here, or units, and my tens here. So my tens, I'm going to put my 0. 5 times 5 is 25. Oh, that's not very clear. 5 times 0 plus 2 is 2. 5 times 0, 5 times 1. Add that to 10 times 5 is 50, or 1 times 5 is 5. 1 times 0, 1 times 0, 1 times 1 is 1. Add them together, so we've got 5, 7, 0, 5, 1. Okay, so we've got 1, 5, 0, 7, 5. But now we've got to put these 2 decimal places back in, that one, and our decimal point will go there. So I'm going to write it a little bit more tidily. So that's 0. No, that's not going to work either. 7, 5. Let's approximate. 10 times 15 is 150. Yeah, 150.75. I'd say that's correct, and yes, it is. So we've got 3 more to do. 1, 2, 3, 4. Yeah. We are on number 5. All right, 14.2 multiplied by 2.56. Okay, take out the 3 decimal places. So we're going to now work out 142 multiplied by 256. Gosh. Okay. This is big. All right, so we've got our ones, we've got our tens, and we've also got hundreds. 6 times 2 is 12. 6 times 4 is 24. Add 1 is 25. 6 times 1 is 6. Add 2 is 8. I'm going to add that to 5 times 2 is 10. 5 times 4 is 20. Add 1 is 21. 5 times 1 is 5. Add 2, 6, 7. Add that to 2 times 2 is 4. 2 times 4 is 8. 2 times 1 is 2. Let's put that with a different colour. 2 plus 0 is 2. 5, 0, 0, 5. 8 plus 1 is 9. Add 4, 10, 11, 12, 13. 7, add 8. Well, 8, add 7. I prefer to do it that way because I can say 8 and take 2 away from the 7 to make to 10. And 7 take away 2 is 5. So I do 8, add 2 is 10, add 5 is 15, add 1 is 16, and then 2 plus 1 is 3. So I think the answer is 36. Well, 3, 6, 3, 5, 2. It's like 36,352, but we've got these 3 decimal places to put back in, haven't we? So 1, 2, 3, and the decimal point will go there. So it's 36.352. Yes. Okay. Number 5. I'm going to do number 6. Okay. 3.04 multiplied by 2.984. Okay, so we've got 3.04 multiplied by 2.984. Okay, so we have 1, 2, 3, 4, 5 decimal places. Okay, so this is a tricky one and we're doing really long numbers here. Okay, so we've got 2, 9, 8, 4 multiplied by, remember I said multiplication is commutative, so we can do it the other way round. I'm going to put the big number at the top. See, saying that, out of these two numbers, which is the biggest? Is 3.04 bigger than 2.984? Or is 2.984 bigger than 3.04? I'm going to leave that there. Can have a little chat about it. Okay. Right. 3, 0, 4. Well, we're multiplying by the ones and the tens and the hundreds. And then, as I said, I always put the double line where I do my answers, but it's nice if that's a little bit more clear. Oh, it's a bit wavy now. Okay, so I've got the ones and we've got the tens. Underline that, put the 0 in, and we've got the hundreds. Underline those two, put the zeros in. Choose a different colour. Let's choose an orange. Okay. So we've got, let's start with the ones. 4 times 4 is 16. 4 times 8 is 32. What's 8 to it? 16. 3, it's 24. 4, it's 32. Add 1 is 33. 4 nines are 36. Add 3, 37, 38, 39. 4 twos are 8, 9, 10, 11. 0 times 4 is 0. 0 times 8. 0 times 9. 0 times 2. And then 3 times 4 is 12. 3 times 8 was 8, 2, it's 16, 3, it's 24, 25. 3 9s are 27, 28, 29. 3 2s are 6, add 2 is 8. So we've got 6. This is why it's useful to have columns so you can see and keep them underneath each other. 9, 10, 11, 5, 6, 7, 9, 10. 8 plus 1 is 9. So we've got 9, 0, 7, 1, 3, 6. But we've got the numbers 3 multiplied by 2. So you're sort of thinking that it's going to be 6, but this says 2.9. So it's not like 3 by 3, which is 9. It's not 907,136. So let's count. We've got 1, 2, 3, 4, 5 decimal places to put in. 1, 2, 3, 4, 5 decimal places. So the answer is 9.07136. Yes. Now looking at these two numbers, is 3.04 bigger than 2.984? Which is the biggest? Let's look at the digits on this side. That's a 3 and that's a 2. So straight away we know that that is correct. Even though that's a longer number, there's those 3 digits on the part side, not the whole side. So we've got to look at that biggest digit first to compare them. And if that digit is smaller than that one, then that is not correct. So number 7, let's do grey. Okay. 17.02 multiplied by 5.212. 17.02 multiplied by 5.212. Okay. Ooh. All right. Okay, so how many places have we got? We've got 1, 2, 3, 4, 5. 1, 7, 0, 2. Oh goodness, that's got 1, 2, 3, 4 digits. That's got, oh, they're both the same number of digits. So it doesn't really matter which way we put them. But we're multiplying by ones, and then tens, and then hundreds, and then thousands, and then we've got an answer. Huge. Ones, tens, don't forget, underline it, pop it in. Hundreds, underline them, put them in. Thousands, underline them, put them in. Okay, and we're adding those all up. Okay, let's choose a contrasting colour. Blue, that'll work, won't it? So we've got 2 times 2 is 4. 2 times 0 is 0. 2 times 7 is 14. And 2 times 1 is 2. Add 1 is 3. 1 times 2 is 2. 1 times 0 is 0. 1 times 7 is 7. 1 times 1 is 1. 2 times 2 is 4. 2 times 0 is 0. 2 times 7 is 14. 2 times 1 is 2. Add 1 is 3. I should have put that underneath. Let's just tidy this up a bit. All right, put it there. Okay, then we've got 5 times 2 is 10. 5 times 0 is 0 plus 1 is 1. 5 times 7 is 35. And 5 times 1 is 5, 6, 7, 8. Okay, so let's answer that. So 4, make sure it's clear, 0, 2, 4, 4, 8. 3 add 7 is 10. 4, 5, 6, 7. 5, 6, 7, 8. And gosh, because this is at the side, I nearly forgot it then. So maybe I should have done that to include it. And 8. So my answer now is, what colour is it? It's like a dark grey, isn't it? 8870. 8870824. Okay, how many decimal places have I got? I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's a bit big. Okay, still big. That's better. Okay, so let's look at this number. We've got 17 times 5. What's 17 times 5? 5 times 7 is 35. And 5 times 1 is 5. Add 3 is 8. That is approximately 85. So it's 88.70824. Okay, let's get this up here. There. Okay, well done. Those can be quite tricky. They can be tricky, but I think once you've understood how to do long multiplication, I think it's much, much easier, and it's essentially trying to work out which number to put at the top and the bottom. But if you take the decimal point out, it makes it much, much easier. You're always better to put the number that has the fewest number of digits. You're better to put that at the bottom, because that determines how many rows you've got in your long multiplication. So if you've got a 2-digit multiplied by a 4-digit, you're better putting the 4-digit at the top and the 2-digit at the bottom. All right, hope you have a lovely rest of the day, and thank you ever so much for joining me. All the best. Take care. Bye.